So at this point, I'd like to go ahead and show you how to analyze some of these hardware crashes. We'll go ahead and start with a stop 9F, which is a driver power state failure, and then we'll finish up with a stop 124, which is a WIA uncorrectable error. So here we are. I'll go ahead and bring up the debugger. Again, we want to always start that in administrative mode. I'll then bring up a crash dump, open crash dump. Here we are. We've got crash dump 1 in module 2. And a lot of information goes scrolling by. But the one thing you'll want to focus in on right away is the fact that the debugger's command prompt has a 14 there. That means that the crash CPU was CPU 14. If you got multiple crashes and they all occurred on CPU 14, that is very high probability that that may be your problem processor. So what we'll do to start out with is just do a bang analyze dash show. And this is going to essentially reveal a bit about this bug check, which is, as you know, a driver power state failure. A driver failed to complete a power IRP within a specific time period, and it tells us that argument 1, the power transition timeout waiting to synchronize with the PNP, that's the plug-and-play subsystem. And then we can see a timeout of 258 seconds. That's in hex. So what we can quickly do is a little math. 258 is equal to 600. And 600 seconds is 10 minutes. So this power IRP had been outstanding for 10 minutes for some reason. Now, a good place to start, as you may know, is the online help. So we're going to go ahead and take a look at the bug check code reference guide for blue screens, and we're going to go to a stop 9F. Here we are. A stop 9F is this driver power state failure. So let's go ahead and take a look at this. It indicates, as we know, that a power state failure, we had an inconsistent or invalid power state. And the different parameters tell us, well, if parameter 1 is a 1, then it's a device object. And then here's the cause. The device object being freed still has an outstanding power request that has not completed. If you remember, ours was a 4, which is a timeout. A timeout in seconds. The power state transition timed out waiting to synchronize with the PNP subsystem. So there's a number of other things it could be, all based on the different arguments that were passed to the bug check. So at this point, there's several different threads that we're executing at the time that are important. There's the current thread that we can look at with the bang thread command. And we could see that's a system thread. More specifically, it's the idle thread. And if we look at the stack of the idle process, you could see it was executing in the idle loop. It was in the idle loop before it tried to retire the various DPCs, or the deferred procedure calls. And at that point, it found a DPC and it was asked to build a device notify list watchdog, and then it did a bug check because of a power timeout. So the system crashed as a result of this thread. This idle loop was told to process a DPC, which was a result of a power timeout. So as you may know, in the bug check codes, there's several arguments. One of them was argument number 3. If we were to do the bang analyze dash show again, we would see that here is the thread currently holding or wanting the PNP, that's the plug and play lock. So let's go ahead and take a look at that thread, see what it was doing. All right, so we could see again that it was a system thread, and if we go over to view its stack, you can see that the thread started up at the bottom. It then is a worker thread doing a PNP device action. It attempts to lock the device tree, and it attempts to acquire a resource exclusive. And there it sits, waiting for an exclusive lock. Okay, so the next command we might want to do at this point is to do a bang locks to see what locks are out there and which ones are exclusively owned. And we can see here we've got the NT PI engine lock, which is the one we're interested in because it is exclusively owned by this particular thread right here. That's because there's an asterisk. We know that this thread owns the lock, and we have two other threads here waiting on that lock. So the best thing to do is now look at this third thread and see what it was doing at the time of this crash. So I'm looking at this thread, which was also a system thread, and if we look at the stack over to the far right, we can see what it was executing. It was doing a thread startup, it was doing a PNP delay remove worker, it was trying to delete locked device nodes, it was trying to remove a device. So the remove device function handed off to the NDIS, which is a network driver, where it tried to do an IRP remove device. And there it sits there and waits. So for some reason, it was unable to remove a device. Now, if we look at this thread a bit closer, look at the amount of time that it was waiting. It was waiting exactly 10 minutes. Remember, from our timeout of 258 hex seconds is 10 minutes exactly. So this thread was the one that was trying to remove a device, and for some reason the driver was unable to do so. Now you can see that this thread also had an outstanding IRP, or an IO request packet. We could take a look at that request packet and get more information. So I'm going to do a bang IRP, giving it the address of the IRP. And as you can see here, we've got a particular function being executed. This is the remove device IRP. So it was being removed, and you can see here that it also says that the module loaded, but symbols could not be loaded for this particular driver. So now we know that this driver, the QLXGND64.sys, was trying to remove a device. We can get a bit more information about it by doing a bang dev stack, giving the ID of the device that you'll find right here. So we issue that command, and we can clearly see now that the device instance is off the PCI. It's essentially an adapter, and that adapter is the QLogic NIC controller. So for some reason, this driver did not handle this too gracefully. So in summary, the system bug checked itself with a driver power state failure when the thread timed out waiting for 10 minutes to execute a remove device IRP to a QLogic NIC. As it turns out, in the system event log, 10 minutes prior to the crash, an entry was logged indicating that the QLogic NIC adapter had reached critical temperatures and was being shut down. So evidently the QLXGND64.sys driver didn't handle the shutdown too gracefully.